So this is part 3, and I want to start taking a look at actually the Great Pyramid and its geometry. I've shown you a bunch so far as in Stonehenge, and of course the purpose of this series is to show you the similar geometry that both are using. In fact, there's more megaliths out there that are using it as well, but everyone is familiar with these two megaliths. But they're all pretty much telling the same story. They're using the same ratios and so forth. But we're going to start taking a look at the Great Pyramid today. So what you're looking at right here is a vector graphics model on Wikipedia of the Great Pyramid. So if you go look it up on Wikipedia, the Great Pyramid, you'll find this. There's a couple of models out there. This one here is by far the most accurate that I've seen. And I say that because when you start plugging in the geometry, testing things like the 3, 4, 5 circles, the various figurative geometry like centered squares and then other pentagons and things like this, the harmony of the way the geometry works all over this particular image, it's always sound. It always seems to work well. There's another model out there that it looks like it's trying to replicate the the flaws. For example, that instead of putting a flat line up here at the top, they kind of show there's like a mound of stones or something like that up there, and they're not even. And even though that makes it look like it's more realistic, it takes away from the actually geometry. And this is where this is really important using a vectors graphics program. So if you notice how small and thin these lines are, that's going to be really important, and I'll show you why here in just a second. So this is what I gathered right here I took this image and downloaded it and put it into Inkscape. Whoever did this image actually did it in Inkscape, and I have a feeling that they were also pretty familiar with what's going on with the geometry. So before we get started, let's just get a couple measurements here. So it says that the Great Pyramid was originally 480.6 feet high, and that would be from the base of the pyramid, not including the underchamber, and 755.9, which is basically 756 feet long on each side. So those are the measurements we're going to take in with this. And of course there's also the subchamber that we'll take a look at as well. But this is what we need to get it to. And if you remember, I was showing you with Stonehenge that in order for me to emulate reality in the vectors graphics program, what I do is I take whatever is 1 foot in reality and I translate that as 1 pixel inside the vectors graphics program. That way everything remains the same as far as the ratio. And the reason why this is important is because if you recall, Stonehenge has a 360-foot diameter circle that surrounds it. Someone was very specific about the measurements of this thing. So if we're going to compare Stonehenge to the Great Pyramid, then we need to show some kind of a correlation between the measurements there and the measurements of the pyramid. The other reason why that I keep track at this detail is because as we are checking things, the numbering system that I've been showing you as far as everything having a digital root of 9 becomes very important. This is the Great Pyramid. If you notice, you can barely see it, and the reason why is because the lines are so thin. This is the way the person did this. The reason why the lines are so thin is because when you start dealing with very highly detailed floor plans and things like this, the lines themselves actually carry a certain thickness. So if you see this person right here represents somebody who's roughly 6 feet tall, standing inside the king's chamber. If you notice these lines that you see here, these lines are 0.2 pixels thick. So it's 1/5 of a pixel wide. The reason this is important is because if we're translating feet to pixels, then we need to understand the distances here And if we have too much or the lines are too thick, it's going to throw off our understanding of what the measurement is here from here to here. So the lines themselves, the thickness of the lines themselves actually become very important. So the next reason why that I'm so precise with the measurements that you see here is because every measurement, every piece of geometry that I create, from the circle, from whatever size circle it is to however large it is, whatever size square or triangle, each one of them are given a particular number of measurement associated with the numbering system that I've been showing you with digital roots of 9. For example, this particular fruit of life with the circle surrounding it, well, the circle, if you look up here at the top, is 360 pixels in diameter. This translates to 360 feet in diameter in reality. So that means that if you take this and divide it by 5 smaller circles, each one of these circles are exactly 72 pixels wide. And so knowing all of this, I would basically translate this to 72 feet wide each, covering a whole diameter of 360 feet. So just to show you how tedious this can actually get, so if I turn on these circles here, as I go through these things, each one has a certain number. And if because the lines are a certain thickness, if I ever adjust the size of the circles with the lines on them, then I have to renumber all of them again, because the lines, as the thickness of the lines grow in proportion to the actual geometry itself. So if you remove the borders, or if the borders start to get thicker, you have to readjust all of the numbers inside of each one of these circles. So this is 18. Look at the top there, right here, 36, 54, 72, and this goes out to 3 decimals, so it goes out to the thousandth digits. So each one of these circles is given a number. I had to go through each one of these and do that. The reason I have to do this is so that I can show that this numbering system is in complete harmony with what I'm showing you inside of the Great Pyramid and inside of these megaliths. This is what they're doing, and they are trying to show us something by doing this. Okay, so what we're going to do is we're going to show you a frame of reference so that we can take you over to the Great Pyramid. And what that basically is the 360 foot in diameter circle that surrounds Stonehenge. So this line that you see right here, if you notice, it says 360 at the top, 360 pixels, which translates to feet in the real world. So this center area, if you recall, is 72 feet in diameter, and the best way to show you that is using the fruit of life. By using the fruit of life, we can see the 5 of them make up the diameter of the circle, and the center one that you see here just surrounds the inner stones. So that's our frame of reference. So now we're going to take that over into the Great Pyramid. So let's take Stonehenge and turn it off. And then let's turn on the Great Pyramid. And let's take a look at some frames of reference. So first of all, let's just get a measurement of the Great Pyramid so we know we're dealing with the correct measurements. So if I back out just a little bit and I click on this outer frame, you can see that this is covering the whole pyramid all the way up to the top. And if you notice, the width is 756 pixels, which translates to feet, as we saw inside of Wikipedia, and the height is 480.6 feet. So this is a 360 foot diameter circle that fits inside of the Great Pyramid. So let's turn on our internal chambers and so forth inside the Great Pyramid. And what I want to do is turn off this fruit of life real quick. And let's turn on some squares. And let's just take some of the density off here real quick. Let's make it 5 squares. So here is our 3, 4, 5 squares. If we were to pull up our circles, we would have our 3, 4, 5 circles right here. So the outer one here is the 360. This is 288. This is 216. This is 144. And this is 72. So if we turn on, first of all, let's take a look at, let's turn off our circles so we can just look at the squares and make it simple. And then let's turn on the internal geometry, or in the chambers of the Great Pyramid. So the first thing that you're going to notice when you take a look at this is that these squares are falling right in line with the passageways that you see for the chamber that you see here and for the king's chamber. You notice this square splits this king's chamber right in half. So we're talking about geometry that's pretty much exact. What I want to do is I'm going to realign these squares real quick so that they're all aligned to the base of this pyramid, so we can get an idea of the distance of height of the different chambers on the pyramid. So I've selected all of the 3, 4, 5 squares, and now I'm going to align them to where they are all touching the base of the pyramid here. So now they're all aligned to the bottom. So this particular square here is 72 feet. So you can see that it's actually 72 feet to the first chamber. To the king's chamber that you see right here, it's 144 feet up. At the top of the king's chamber, it's 216. And then once you reach the 288, or the fourth square that squares the circle, if you'll notice, it just touches, or just kind of exceeds the inside of the inner walls here, but it also touches exactly the circle here that you see, which is the large 360-foot diameter circle. So you can see they're actually dealing with 72 feet here. They're dealing with 360 feet, and we can see by the placement of these different chambers, one is 72 feet up, the other one is another 72 feet up from that. The top of the king's chamber is another 72 feet up. So you can see that the 3, 4, 5 is being used all over this pyramid. So let's turn off these squares real quick. We'll come back to them in just a second. And let's take a look at what our 360-foot circle in diameter does. Let's just turn off these squares real quick. So here's our 360-foot circle. So what I'm going to do is I'm going to take this circle and I'm going to multiply it times phi. And let's see what happens. So I'm just going to go ahead and copy that, and then we're going to say 360 times 1.618. So we're going to make it that much larger. And if we do that, we'll notice that this line here passes right up here, but it's kind of odd because what it's doing is kind of a little bit farther up, or a little bit further down from this top point, but a little bit further up from this bottom point. Well, what I've discovered is they're typically using this right here plus the peak of that. So if we turn on that little piece of the pyramid right here, this is what they're looking at. And then in addition to that, in order to keep things in harmony, so if you notice, this is 582.48. Now what's interesting about this is 360 times phi is what this number is. The digital root of this is actually 9. So 13 plus 2 is 15. Plus 12 is 27, 2 plus 7 is 9, which is very interesting. But here's what they're doing. So they are keeping within the same numbering system, but they're actually going to 0.6 rather than 1.618. They're using 1.6. I believe that the reason that they're doing this is because symbolically they're showing that you can never actually reach the number phi. So what they do is they represent that by using 1.6. So if we take this right here, we delete this and use 360, and this time we're going to multiply 360 times 1.6, and it gives us 576, and we're going to apply that, and if you notice, it actually sits right at the peak of that if this were built all the way up. So 360 times 1.6, which is what they're using here for this calculation. And if we take a look at the circles real quick, so let's take a look at some circles. And if you notice, as we increase these circle sizes, this particular circle size right here falls within this numbering system, which is actually what they're doing. If you notice the way that these chambers are falling right on the edges of these circles, for example, 72 represents that area that we saw in Stonehenge. So if we take a look at Stonehenge real quick, the Great Pyramid compared to Stonehenge, and this area right here represents the same distance that you see on the Great Pyramid from here to here. So I want to show you a couple more pieces of geometry inside of the Great Pyramid that are kind of confirming this whole 360-foot diameter and 72 over and over again. So if we take a look at this pentagon that you see right here, or this 5-pointed star, it is actually 360 feet high, as you can see, because it is the same height as the circle. But you'll also notice that both corners of the stars touch the inside of the pyramid. So they're once again showing this 360-foot diameter importance. Now I want to show you how they're actually using the number 9. Seems to be very important in all of this. What you're actually looking at in the construction and the dimensions of this thing is they're actually using octaves of 9 in their measurements on the inside of these various structures. Let me kind of show that to you real quick using some figurative geometry called centered squares. So first of all, let's turn on. So there's a bunch of squares at high density. Now each one of these squares, if we take a look at them, are, it looks like, see, this one is actually 18.25, which has been adjusted. So this is one of those situations now where I have to probably moved it or added something or changed the size just slightly. Now it's exactly 18. Now obviously you can't tell a difference on your screen, but it's important that I show this to you. One of the things I want you to see, if you take a look at these squares, is I want you to notice the way that these pieces of the King's Chamber fit right in between these squares, and how all of the geometry seems to fall right in line with the where things are touching and so forth. So not only are they 72 feet up, but the width of the King's Chamber, if this is 18, that means that if I were to bring this over here, this is basically 18 feet wide. So one of the things that I can use is kind of show you some of the geometry and kind of the harmony that's associated with it, is to use what's called centered squares. So centered squares are basically these dots that are every other square. Let me just show you what the configuration looks like. So we'll just turn those on real quick. So if you notice, they follow the line of each line. They're right in the center each time, and they're either on the outer or they're right in the center of these. Now this tells us a lot of information. Like, for example, if you take a look on the sides of the pyramid, you'll notice that these things are kind of dipped, or divided almost right in half, and it's touching the inside of this thing. And when the lines come down, where the lines goes through the pyramid here is right where this airway is coming up. It's just actually tangent to this circle right here. This is actually all over this kind of thing, and one of the things really neat I wanted to show you was the different chambers. So if we take a look at the centered squares and their placement, you can see that these circles are located along the width of the king's chamber. So if I back out real quick, and you can see what this looks like, this is actually our 360 foot diameter square. These are all 18, so if you want to take a guess at what the smallest circle that we're going to use that we find in the Great Pyramid, that would be this little circle that you see right here, and that little circle is 9 feet in diameter. So if we take that particular circle, and let's just copy that, and let's just look at a couple of things here real quick. So one of the things you'll notice is that the casing stones seem to be very close to about 9 feet in diameter. So what I noticed is that at the very top here where this is located, the pyramidion that you see right here that I placed on the top, well, I decided to see if this right here would fit in that. But before I did that, I decided to see, well, what would happen if I lined the whole inside of this pyramid with 9-foot circles. So let's turn off our centered squares real quick, and let's turn off these other squares, and then let's look at this. So what I did was I created a bunch of 9-foot circles, and I aligned the whole base of the pyramid, brought them up here, and brought them all the way to the top. And if you notice, they split right down the middle of the pyramid right here, and at the very top as they come together right here, this 9-foot circle fits inside this thing really nicely. So I'm seeing the same geometry all over the place. So for example, we could take this circle right here, and we could place them side by side and notice that this is roughly 18 feet in diameter. So 9 appears to be what they're using that's really small, and we can find similar things in various areas of the pyramid. 18 is the next size, 36 is the next size. You've of course seen 72, and so on and so on. So I think we're going to conclude this part, and we'll pick up the next time with more information on this. But one thing I want to show you real quick that we're going to cover next time is if you take a look at this is the fruit of life. It's inside this 360 foot circle. But if you notice, that doesn't reach the top of this thing. And what we'll find is that if we create a fruit of life that is 9 circles in diameter, then we actually reach the very top and the very bottom. And if you notice, these right here rest right on the base of the pyramid. So you can see that the harmony associated with this thing as we continue. So I'll pick up where we left off the next time. You can see the 3, 4, 5 circles and how they're being used inside of the pyramid, and how it is related to Stonehenge in this sense. So anyways, we'll pick up next time. You guys have a great weekend, and I'll talk to you soon.